There's this breakthrough discovery about how lung cells decide whether to repair damaged tissue or mount an immune
Yep.
defense. It's pretty fascinating, really shifting our view on lung regeneration.
Yeah, that's intriguing. So these lung cells, the alveolar type 2 cells, they essentially have a dual purpose, right?
Exactly. They serve as both the protectors by fighting infections and the repair team by regenerating alveolar type 1 cells, the ones responsible for oxygen exchange. And the interesting twist here is that these cells can't do both at the same time.
So it's like they have to commit to one role at a time. That really underlines how delicate lung function can be.
Right. It's like this molecular switch inside them that tips the balance. The study talked about a circuit involving PRC2, C/EBP alpha, and DLK1. You can think of C/EBP alpha as a sort of clamp that holds them back until it gets released after injury.
Yeah, I get that. And they mentioned that in newborns, these alveolar type 2 cells stay flexible for only about 1 to 2 weeks, correct?
Yep, exactly. After that early period, they become fixed in their roles. This might explain why regenerative capacity falters in diseases like pulmonary fibrosis and chronic obstructive pulmonary disease.
That does sound promising for targeted therapies. Like if we could manipulate this switch, we might boost lung healing without sacrificing infection defense.
True, but here's where it gets tricky. While adjusting, say, C/EBP alpha activity could enhance repair and possibly reduce scarring, we have to be cautious about not hampering the immune defense.
Right, it's a balancing act. So, are there potential applications for things like early diagnostics too? It seems like identifying when these cells get locked into one state could signal the progression of disease.
Absolutely. It's almost like having a built-in warning system. If we can detect when the switch is stuck, we might catch lung damage early enough to intervene before severe scarring sets in.
Yeah, that makes sense. But I have to ask, isn't there a risk of oversimplifying things? I mean, flipping a molecular switch sounds like it might be more complex in practice.
Well, you're right to challenge that. Manipulating such a critical process is delicate. It's not just a simple on-off button. It's a finely tuned circuit where timing and balance are everything.
Understandably. So while the discovery opens exciting new paths, it also reminds us that real-world applications might face challenges in safely controlling these mechanisms.
Exactly, but ultimately, this research is like a roadmap, giving hope for personalized regenerative treatments and even early biomarkers for lung disease. It could ultimately transform how we approach chronic lung conditions.
Yeah, that's revolutionary. It really is a game changer. Imagining a future where lung repair is boosted before irreversible damage occurs is truly inspiring, even if the path forward is complex.
Definitely. Keep an eye on this field because every step here pushes us closer to giving patients improved quality of life.
For sure, it's discussions like these that make you appreciate how small molecular discoveries can lead to huge changes in medicine.
Absolutely. And while the research is still unfolding, it offers a beacon of hope for those affected by lung diseases.
All right then, here's to further breakthroughs and to wiser, more balanced treatments for lung repair.